We are currently studying the iterator pattern, and as a precursor to the actual pattern, we are focusing a little bit on collections. Collections form the fundamental framework for which the iterator pattern exists, so it's an obvious thing to study and understand well before we move on to the actual pattern itself. So, onward to studying collections in a little more detail. Now, what type of objects can a collection hold? Turns out this is a really important question, and it has multitude of answers depending on the type of collection you instantiate. It's also different across languages. In fact, some languages like Python, a collection is explicitly built so it can hold objects of any type. By this I mean that one collection can hold a string, a boolean, a user-defined object, and anything else. It can also hold another collection, all in the same container. Now, this is not always true of Java. Though of course in Java you can say that everything is an object. So if you have a collection of objects, it can technically hold everything. But that's not the way collections are usually used in Java, and that's typically not the best practice either. Normally, we would like to have some level of type safety in collections. We'd like to ensure that all objects in a collection are either strings or booleans or exactly of the same type. Why is that? The reason for that is because errors of the type where someone using your collection expects, say, a number but it's actually a string, you'll avoid these. In order to avoid errors of this kind, it's important that collections have some level of type safety built in. Now, in Java, all variables have declared types. When you instantiate a variable, you have to specify what type it is. You can't just instantiate a variable and say, I'll decide later what type it is. This is polymorphism. Even in that case, you have to specify what interface that particular member variable implements. Leaving that wrinkle aside, all variables in Java have to have declared types. What does that mean for type safety of a collection? This basically means that Java enforces type safety for a collection. And this it does using something called generics. And we'll see that in a little bit. But what it also implies that we have to declare upfront the type of a variable and also the type that a particular collection holds. This is required in order to ensure the type safety for all objects in a collection and also allow Java to enforce its type safety on types as well as the collection. When I say Java enforces type safety on collections, it means that type safety for all collections, be it lists, maps, or sets, all of these are enforced in Java. How does Java do this? Here leads to something interesting that we are going to discuss. Java enforces type safety rules via generics. Generics are a very core part of the Java language and makes Java incredibly powerful, easier to use, easier to maintain, and more specifically helps enforce type safety for a whole variety of objects, especially collections. Generics allow us to move away from treating everything as an object. We can now treat everything as its specified type, provided that class, or in our case the container, implements generics. After all this build-up, let's take a look at some code and see what generics really are and see how cool they are. I'm not sure you'll get it all, but it's interesting to take a look at it and you'll see the power of it. Take a look at the code that you see on screen. There's a whole bunch of stuff going on there. Let's read it inside out. You see a pair which takes in a string and integer in that funny angular braces, then you see a list outside. This means pair is an object that holds two other objects. You might have already used this class before. One of those objects is a string and the other is an integer. So you have a pair generic class, and this specific one holds a string as the first object and an integer as the second object. By specifying it within angular braces like this, you are enforcing and you're helping Java enforce that the first object needs to be a string and the second object needs to be an integer. What these objects are can be specified between the inner pair of angular braces. The greater than less than sign are called angular braces when they are used with generic templates like this. Okay, what do you have after the pair? There's a whole lot of other stuff there as well. Next is we have a list of such pairs. And by such pairs, I mean a pair of string and integer. We have a list of these pairs specified by the outermost list keyword. So we have a list of pairs of strings and integer being the part of the pair. Alright. Now, the types enclosed inside the angle brackets or the angular braces are called the template parameter. So in the case of a pair, the string and integer are the template parameter, and in the case of a list, it is the pair of string and integer. The types enclosed inside the brackets are called the template parameters. It's important to get these terms exactly right, because when I use them later, you need to understand what they actually are. So we have a list of pair of string and integer. Now, a list is just an interface. We need an actual implementation of this list, and you should see that after the new keyword in that piece of code. You can't actually instantiate an object of an interface. And an implementation of list we just saw as a part of the last class is an array list. So array list is a built-in Java class that inherits from list and implements the list interface. So we go ahead and instantiate an object of the class array list. Okay, let's go back to our class hierarchy, which shows the collection, the list set and map and all its implementations. Now, that's a lot of different collection classes, and I've just told you that this is not the exhaustive list. There are a whole bunch of other collections out there in the Java world, and you can define your own as well. Now, it seems like it'll be a real pain to actually work with all these different classes. Each of these probably have their own specific behaviors and do a lot of different things. So how do you actually work with so many different classes? Actually, it's not a problem at all working with a whole host of collection classes. And the reason for that is there is a uniform and intuitive way to work with them all. You don't need to know different ways of dealing with different collections. You almost always deal with them in exactly one way, and that involves the iterator pattern. We are finally to the nub of what this class is going to be about. The iterator pattern allows us to deal with all collections in a very uniform way, making them easy, intuitive, and you don't have to really think about what you need to do to interact with them. Now, above the collection interface exists another interface called the iterable. This is once again a generic interface, means it can take in any kind of type. The iterable is above the collection interface. Now, Every Java collections implements the interface iterable T. The iterable T interface has just one method. That's the only method that we need to concern ourselves with, and that's what makes working with collections so easy. And that one method is called Iterator, and it returns an iterator. So we have an iterable T which has one method, iterator, which returns an iterator. This means every Java collection offers a way to get a corresponding iterator object for that collection. I'll leave you with the last important line. Every Java collection gives you an iterator, and you work with that iterator, which means you work with every collection in exactly the same way.